Lesson 6 is on converting measures. And remember, the two main points for converting measures is that they, when you have things that are equal, you can make two fractions out of them, and then you're going to choose which one works in your given situation. And then also, when you are given a number in a problem, you keep the units on it and write it over 1 to make your first fraction. So we'll take a look at those in the first couple problems. So, a movie is 180 minutes long. How long is the movie in hours? So, what do we know about hours and minutes? Well, we know that there are 60 minutes in 1 hour. So, the equivalency that we would write then is 60 minutes equals 1 hour. And based on that, we can make two different fractions. We can make 60 minutes over 1 hour, or we can make 1 hour over 60 minutes. Okay? So, the first thing that we do to start the problem is take the information that we're given and write that as a fraction. So you take the number with its units and write it over 1. The information they give you in the problem will almost always be over 1. In this section, for sure, always over 1. So now, in our next fraction, in order for minutes to cancel out, I need to have minutes in the bottom of this fraction over here. When they're diagonal, they will cancel out. So I choose the fraction that I've already written over here that has minutes in the bottom. Well, that's this one. So I have 1 hour over 60 minutes. Minutes are diagonal, so they'll cancel out. And then I'd be left with hours, which is what the question is asking. So when I multiply by a fraction, these two fractions are being multiplied, I multiply by the numerator and divide by the denominator. So this would look like 180 times 1, which is still 180, divided by 60. And I can take 180, treat that as 18 divided by 6, which is 3, and then so it would be 3 hours. Whatever units you didn't cross out are the units of your final answer, so they're hours. If I count by 60s up to 180, I have 60, 120, 180. A recipe calls for a half pint of cream. How many ounces of cream are required? Well, if we look at our table on page 37, a half pint, or 1 pint, is equal to 16 ounces. So we can make two fractions with that. We can have 16 ounces over 1 pint, or we can have 1 pint over 16 ounces. So now we're going to start this specific problem. The recipe calls for a half pint of cream. So I know that a half is 0.5, so I'm going to use that so I don't have too many fractions going on. So I have 0.5 pints. Remember, keep the units so you can tell where to put the next units. This one has pints on the top. The next fraction then will need to have pints on the bottom to cancel out. So I look back at the ones that I've written, and this is the fraction that has pints on the bottom. So I write 16 ounces over 1 pint. The pints cancel out. And then, remember, anything on the top of a fraction I multiply by. Anything on the bottom I divide by. So 0.5 times 16 divided by 1 is still going to just be 0.5 times 16, which is 8. And the units that I haven't crossed out yet are ounces. The bottle of water weighed 2 kilograms. What is its weight in grams? So I look, and the conversion there says that there are 1,000 grams equals 1 kilogram. So two fractions I can get out of that are 1,000 grams over 1 kilogram, or 1 kilogram over 1,000 grams. So if the bottle of water weighed 2 kilograms, I would start and I'd say 2 kilograms over 1. Always take the information they gave you, put it over 1, and then I'm going to multiply that by a fraction. And since I see kilograms on top here, my next fraction will have to have it on the bottom to get rid of it. So I pick the one that has kilograms on the bottom, and I fill in that information. 1,000 grams over 1 kilogram. Since kilograms are diagonal, they'll cancel out. When I multiply by a fraction, I multiply by the numerator. So 2 times 1,000. And then I only have ones on the bottom, so I'm dividing by 1, which keeps it the same. So that's 2,000. And then I have grams as my units left, since I did not cross them out. In number 4, it says 3/4 of the students wore the school colors. If there are 300 students, how many wore school colors? So 3/4 of the students, 300 students. So 3/4 of 300. Of, remember means multiply. So 3/4 is the fraction 3/4 times 300 students. This is from lesson 5, the fractions. When you multiply by a fraction, you multiply by the numerator and divide by the denominator. So I have 300 times 3, the numerator, divided by 4, the denominator. Well, 300 times 3 is 900. Divided by 4 is, well, let's see. If you don't know that offhand, 4 goes into 9 twice, so 2 times 4 is 8. 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. 4 goes into 20 5 times. 5 times 4 is 20, and that gives me 0. So 225 students wore colors. Each book that Violet carried weighed 2 pounds. If she carried 12 books, how heavy was her load? So this is from lesson 4, which was equal parts, or equal groups, excuse me. So if I have equal groups, that gives me n, the number of groups, times g, the number in each group, equals the total. Well, the number of groups is 12. She has 12 books, times the number in each group, the weight of each book is 2 pounds, equals the total for her load is 24 pounds. Jorge read 23 pages before dinner and 18 pages after dinner. How many pages did he read in all? This is from lesson 3, and this is a combining problem. So you have sum, 23 pages, which he read before, plus more, he read 18 more pages after dinner, equals your total. So 23 and 18, 23 and 10 is 33, and 8 is 41 pages. The students were divided evenly into 5 groups to work on a project. 2 of the groups completed their project before class ended. What fraction of the students completed the project before class ended? Well, if there were 5 total groups and 2 of the groups completed it, then 2 out of the 5. So 2/5 of the students finished before class was over. So this is the part, and this is the whole. After the demolition, there were 20 tons of rubble to remove. Each truck could carry 7 tons of rubble. How many trucks were required to carry the rubble away? So this one's going to be in equal groups again. So from lesson 4. So you have 20 tons of rubble to remove. That's your total amount of rubble. There are 7 tons that can go into each truck. So we want to know the number of trucks that are required. So n times 7 would equal 20. And when you want to solve for one of the factors, you take the known, the total, and you divide it by the known factor. So 20 divided by 7, that's not going to divide evenly, but we can think of it as 7, 14, 21. Well, we need to at least move 20, and that would be required, 3 would be required to do that. So is about equal to 3 trucks. You could also just think of that as the first truck would come by and it'd take 7. That would leave us with 13 tons. The next truck would come by, take 7. That would leave us with 6 tons. And you still have 6 that need to get picked up by the last truck. So 3 trucks. The driving distance from San Antonio to Dallas is 272 miles. Okay, so we have San Antonio to Dallas is 272. Along the route is Austin, which is 79 miles from San Antonio. So somewhere in here is Austin. And this is 79 miles. What is the driving distance from Austin to Dallas? So we can see that we have a combining problem where the distance from San Antonio to Austin plus the distance from Austin to Dallas would equal the total from San Antonio to Dallas. So the 79 plus what we don't know yet, let's call it a question mark. They would have called it M in the book, is equal to the total of 272. So in order to solve for one of the addends, what you do is you subtract the known addend from the total. So 272 minus 79 equals 12 is 3, and that's 9. So 993. And we could check that, and we would do 79 plus 193, and that gives us 272 miles. A serving of 3 cookies of a certain kind contains 150 calories. There are how many calories in 1 cookie of this kind? So this is an equal groups problem. So we have 3 cookies times however many calories there are in a cookie, in 1 cookie, equals the total of 150 cookies. So to figure out one of the factors, we take the total, 150, and we divide it by the known factor, 3. 150 divided by 3 is 50. And so that would be calories. How many hours are in a week? So this goes to unit conversion. So from this unit. So we have how many hours are in a week? Well, the first thing that we need to know are how many days are in a week. Okay, so we have 1 week equals 7 days. Okay, so we're going to call it days. So 7 days over 1. And then the other thing that we have is that there are 24 hours in 1 day. So we can have 2 fractions with that. 1 day over 24 hours, or 24 hours over 1 day. So if I look over here, I have days on top, which means that days needs to be on the bottom in the second fraction to cancel out. And the one fraction that I've written that has that is that one. So I'm going to have 24 hours per 1 day. Days and days cancel out since they're diagonal. And then I need to do 7 times 24. Well, 7 times 20 would be 140. And then 7 times 4 would be 28. 28 and 140 is 168. So 168 hours are in 1 week. Valerie rode her bicycle from home to the market in 12 minutes, spent 20 minutes at the market, then rode her bicycle home in 15 minutes. When she arrived home, how much time had passed since Valerie left home? So this is a combining problem from lesson 3. So we have some 12 minutes she took riding to the market, plus more the 20 minutes she spent at the market, plus some more the 15 minutes it took her to bike home. So 12 plus 20 is 32, plus 15 is 37, so 37 minutes. The glass is 3/4 full. If the glass can hold 12 ounces, how many ounces are in it now? Well, we're being asked what is 3/4 or 3/4 of 12 ounces. So remember, 12 of means multiply. So we have 12 times the fraction 3/4. We multiply by the numerator, 12 times 3, divide by the denominator, divided by 4. 12 times 3 is 36, divided by 4 is 9. Arrange these numbers from least to greatest. So we have negative numbers. That'll be the least. So -2. And then comes 0. And then both 5/7 and 1/2 are less than 1. We just have to decide which one comes first. Well, half of 7 would be 3 1/2. So 5/7 is more than 1/2. So then comes 1/2. Then 5/7, then 1. Compare -5 is less than 4. The absolute value of -2 is 2. Absolute value of -3 is 3. So the absolute value of -3 is greater. And then compare 5 and the absolute value of -5. Well, the absolute value of -5 is 5, so those two are equal. Use the numbers 5 and 3 to provide an example of the commutative property of addition. The commutative property says that it doesn't matter the order that you put the numbers in if you're adding. So I can have 5 plus 3, and that's the same thing as 3 plus 5. Use braces and digits to indicate the set of even counting numbers. So braces, what they're talking about are the squiggly parentheses. And if I'm going to count by even numbers, I start with 2, 4, 6, 8, and so on. The dots, dots, dots mean it goes on like that. What is the absolute value of 0? Well, how far is 0 away from 0? It's 0 away from that. On a number line, graph 1, and two numbers that are 3 units from 1. So if 1's here, 1, 2, 3 would be 2, 3, 4. And then 1, 2, 3 spots over would be 0, -1, -2. If 12 plus 3 equals 15, what other addition fact and what two subtraction facts are true for 12, 3, and 15? So we have 12 plus 3. We can reorder those then and do 3 plus 12 is 15. And then the two subtraction facts are 15 minus 12 is 3. And 15 minus 3 is 12. If 40 divided by 8 is 5, what other division fact and what two multiplication facts are true for 48 and 5? So again, reordering. So 40 divided by 5 is 8. And then multiplication, 8 times 5 is 40. And 5 times 8 is 40. What number is the opposite of 100? Opposite means opposite sign, so -100. Give an example of an integer that is not a whole number. Whole numbers don't include negative numbers, so -2 is an integer, but not a whole number. Give an example of an integer that is a whole number. +2 is both an integer and a whole number. Decide if the statements in problems 27 through 29 are true and explain why. If the statement is false, give a counterexample, an example that disproves the statement. Every counting number is greater than every integer. While integers, remember, include both positive and negative numbers. So if the counting number was 2 that we picked and the integer was 7 that we picked, that would not be true. So this is false. 2 is a counting number. 7 is an integer. And 2 is not greater than 7. It's less than 7. Every positive number is greater than every negative number. This one is true. And you can think of it as all the positive numbers are farther right on a number line than the negative numbers. every fraction is less than 1. This is another one that's false. Proper fractions are less than 1. Oops, false. But 3 over 2 is a fraction. And 3 over 2 is 1.5, which is more than 1. Alright, and then find two solutions for this equation. The absolute value of x is equal to 7. So what two numbers have a distance of 7 away from 0? Well, that's 7, which would be 7 to the right of 0, and negative 7, which would be 7 to the left.